this chapter is all about division. So yesterday we drew some pictures where we drew the circles and then we divided the blocks up into each of the circles, and we used some manipulatives off of our computer. Or we could draw them in order to show how many goes into each of the circles. So remember that division is the opposite of multiplication. So if we know some of our multiplication facts, then we're going to in turn know some of our division facts. Okay, if you know multiplication, then you know division. So we're going to talk about some of the steps in doing a long division problem. Today, we're not going to have a lot of numbers that we're dividing, so we're only going to have to use our steps a couple of times. So the number that goes underneath the bar, the dividend, there's going to be 2 digits there. So it might be like 42 or 14 or 12 or something like that underneath the bar. So once we continue on with this chapter, we're going to be dividing with larger numbers, like 3-digit numbers or 4-digit numbers. But the steps in division are going to always be the same. Okay? So some of the tools we're going to learn are going to help you when you're doing that. So here's your essential question. What are the strategies that can be used to divide whole numbers? So far we have learned about some of the patterns of division, the fact families that go with division, which might help you. We learned yesterday, like I said, about the drawing the pictures and using the models, and then today we're going to actually solve some of the problems. So here's your problem of the day for your whiteboard. If you didn't get a whiteboard, I'm going to grab a couple more so that everybody has one. So you can always work this out on your notes until you get a whiteboard. In a tennis tournament, third place received $1,000, second place received twice as much, and first place received 4 times as much as second place. How much money did each place win, and how much money was awarded total? So you have 2 questions. No one's going to raise their hand and tell me the answer. I want you to work it out on your whiteboard or in your notes for the couple of people who don't have a whiteboard yet. Wait, don't talk to anyone. Do it by yourself. This is your problem of the day. If third place got 1,000, so let's make a little chart here. We have first place, second place, and third place. Third place is 1,000. Second place is twice as much. So how much would that be? 2,000. And first place is 4 times as much as second place. So what would that be?
8,000.
8,000. So how much is the total prize money?
$11,000.
11,000. Good.
I'm trying to raise my hand.
Okay, you can erase your board. So here's our question for today. Our investigating question. What vocabulary do you need to know to understand division? I'm waiting for everyone to make sure everybody hears us before we move on. This is the question. We're going to talk about the question. Oh, hold on. Hold on. Sometimes, unfortunately, on the note page, they have some things that are there that I can't erase, so we have this problem in the middle. So we're just going to try to work around that for our notes. So we're going to do a bunch of examples. In order to know how to do division, some of the vocabulary that you're going to need to know would be, what are the numbers called that are all around the division problem? So you have the dividend, which we've kind of already talked about. The dividend is a number that's being divided. So it's usually the bigger number. It doesn't have to be, because sometimes if we were dividing a decimal, like if we were going to get a decimal answer or a fraction answer, then it wouldn't be the bigger one. But for this lesson, the divisor is always going to be your bigger number. So it's the number that the dividend, I'm going ahead. So the dividend is always the number that goes underneath the bar in a division problem. So in this case, the 24 divided by 6. This is the dividend. So I want you to write that down in your notes. The dividend is the number that is being divided. The divisor is this number. Do you think you could do that any quieter so people can make sure they get all the notes? All you need is a pencil. Is that one? Okay, then yeah. The number that goes up here is called the quotient. So the 24 in this case is the dividend, the number that's being divided. The divisor is 6, that's the number that's dividing into the dividend. And then the quotient would be the answer. So if I made a word problem, if I said I have 24 candy bars and I'm dividing them amongst 6 of my friends, everybody would get 4 candy bars. So your fact family would be 24, 6, and 4, right? Those are the 3 numbers that we're working with. You can use multiplication to help you check your answer by doing 4 times 6 and you get 24. So if you work backwards and you use multiplication, you can always check your answer too. I'm going to show you a couple of examples, and we're also going to do I'm going to show you the steps, and we're going to write the steps down. So unfortunately this doesn't erase, so I'm just going to scratch it out. Our first step number 1, and you're going to write this in your notes, is divide. So you're going to divide the digit on the outside, the divisor, into the first digit of the dividend. Because in today's lesson, there's more than one divisor. That's what we're talking about. So step number 2 is to use multiplication. Multiply to see what number is going to go underneath.
If you're dividing
Just write down these steps, and I'm going to show you an example to go with it. Step number 3 is to subtract. And number 4 is to bring down. Step number 5 could either be repeat or remainder. So either you repeat it if there's another number. If there's no other numbers, then you have a remainder. So you can make this repeat or remainder. So an example is going to be 72 divided by 4. So when a number is written like this, because a lot of times you'll see the problem written across like that, you have to know which number is going to go underneath the bar and which number is going to go on the outside. So basically, you take the numbers and you switch them. So your 4 would go outside and 72 would go underneath. That's what Nolan asked earlier. The bigger number in this lesson will be inside, but later in the year, pay attention. Later in the year, we start to divide to get decimal answers, or if we divide to get a fraction answer. Sometimes your number that's on the outside actually is bigger than the number that's on the inside. And so I'm not going to say it's always like that, because there is a way to divide 72 into 4. It's just going to be a decimal answer. So we haven't been there yet. So I'm not going to tell you it's always like that, where you always put the bigger number. You need to think of it like what I just told you. The first number is the number that you're dividing into, and that goes underneath the bar. And the number that how many times you're dividing it goes outside the bar. So when you see it written across, you just need to know that the first number goes inside the bar, the second number goes outside. So you have to remember that, because like I said, in the future, when those numbers are switched, and sometimes your bigger number is not going to go underneath the bar in future lessons. Angelina.
the 5 steps.
Uh-huh.
Kind of reminds me of like something that we used to do, like the divide. They would like put dad and then mom and then sister and then brother
Yes.
and then the dog.
Yep. So sometimes people make little rhymes or something to remember. So the D, dad, mom, sister, brother, Rover, whatever somebody says. So if you need help to remember the steps, those are just the first letters of all of those words. Okay, so step number 1 is to divide. So I'm going to take this number, the 4, and I'm going to divide it into the 7. Not into 72, because does anybody know just offhand their 72s to know how many times 4 fits into 72? Hold on. You may know if you went ahead and you already solved the problem. That's not what I'm saying is, generally, we don't know how many times 4 fits into 72, and that's why we have to make a long division problem to figure it out. So we're going to divide into the first digit first. So 4 goes into 7 how many times? Show me on your hand. Let's do that so that everybody can do it. So show me on your hand how many times 4 fits into 7. Just once. That's our divide step. 4 times 1 is 4. 4 times 2 is 8. So 4 can only fit into 7 one time. 4, hold on. 4 can only fit into 7 one time. I don't know how to show this to you. If I have 7,
4 plus 4.
7, look up at the screen, up in the blue part. So there's 7 little dashes. If I'm saying here's 4, can I fit 4 more in there again? I can't fit 4 more. There's only 3 more dashes. I can only fit 4 in there once. So I put a 1 up here. And now I go to step number 2, which is multiply. So I put 4 into 7 once. And now I multiply the number I just wrote, the 1. Multiply that by 4. And I get 4. So I put that number underneath. Notice that I put a subtraction sign there because that's my next step. Step number 3 is to subtract. So 7 minus 4 is 3. Step number 4 is bring down. So I'm going to bring down the 2. And now it's 4 into 32. How many times does 4 fit into 32? Nolan?
8.
8 times. And then when I multiply 8 times 4, I get 32. And I'm still following the steps, subtract, and I get 0. Step number 4 is bring down. There's nothing left to bring down. There's no other digits over here to bring down. So now it's remainder because we're done. There's no remainder. There's no repeat. There's no remainder. I pulled this 2 down. This was part of my step, was to bring down the next number. I was right here at this step. And now I get 4 into 32. 4 into 32 fits 8 times. 8 because 8 times 4 is 32. Because 4 goes into 32 8 times. That's a basic fact. Okay? Let's do another example. So my final answer is 18. Remainder 0. So some of your questions here today may have remainders. If they do, you would just put the little R next to it. Here's another example. I'm going to erase everything because 4 goes into 32 8 times. Okay, let's do another one. We're going to do more examples. Here's one. 68 divided by 5. So remember, we're gonna switch them, and we're gonna put the 68 underneath the bar, and we're gonna put the 5 outside the bar. I just want to tell you that what we're doing here today is nothing new to you. Like, you've done this before. You did this in 4th grade. It's just there's a lot of steps, and if this is really one of those lessons that during your working time today, if you turn to your neighbor and you start like a conversation about something else, and then you try to get back to your problem, you're probably not going to get the problem right, because it's one of those things that if you're in the middle of it and you stop and look away and do something else and then you look back, you can't remember where you were, because it's just kind of a long problem. You have to work through the whole thing in order. So step number 1 is divide. So I'm going to divide 5 into 6. So how many times will 5 fit into 6? Show me on your hand. 1 time, right? Because we can't go over. So it fits 1 time without going over. And now we multiply. 1 times 5 is 5. Now step number 3 is subtract. So 6 minus 5 is 1. Step number 4 is bring down. So I'm going to bring down the next number. Anthony, this was your question last time, was how did I get that number? Because step number 4 is bring down. So that means after you subtract, you bring down the next number that's in the next place value. And now we're going to divide again. 5 into 18. How many times, show me on your hand, will 5 fit into 18 without going over? See how it's important that you know your basic facts? 5 goes into 18 3 times. And then when we multiply 3 times 5, we get 15. And then we subtract, so that's step number 3. And we get 3. And then the next step is bring down, and there's nothing to bring down. So now step number 5 was repeat. Remainder or repeat. And so because there's nothing to, hold on, let me finish my sentence. Because there's nothing to repeat, because there's no numbers to bring down, the 3 becomes our remainder. So our final answer is 13, remainder 3. Yeah.
We only have to repeat if the number that you are dividing, like, so what's the number that's under, we have to repeat if it's like a non-group.
Right. So let me relate what we're doing today to what we did yesterday. So watch the screen. Watch the screen. Here's what we would have done yesterday. Watch the screen. Not everybody's watching, that's why I've said that 3 times. Yesterday, we would have done this. 1, 2, 3, 4, 5, 6, and then 8. Oh, I guess I could have pulled those over from the side. And then we would have made 5 circles. Then we would have taken each of these and we would start putting them into the circles. So I'd put this one here, I put this one here, put this one here, and then I'd have to break this apart and make it 10. And then I would take all of these, which would be 18, and I would go through all of these circles and see how many I could fit in here. So I would go 1, 2, 3, 4, 5. There's 10. There's 15. 16, 17, 18 are left over. So this is what we did yesterday, where we had to draw all the pictures. Today you don't have to draw the pictures. Today we're just doing it's called the standard algorithm. It's just the steps that you follow to get the answer. So do you see how each of these circles had 13 in them, a 10 and 3 ones, and you have 3 at the end that's a remainder. So my answer is still 13, remainder 3. We're not doing anything different than what we did yesterday. Like, it's the same type of problem. We're still doing a division problem and we're still getting the same answer. The difference is the way we're solving the question. Next example is on your whiteboard.
I still don't have.
Are we on chapter 3, lesson 3?
Yes. Let's read this question together. Go get in the bin over there and get a marker. Over there, there's some. Ten seconds. 15 seconds. Cameron, 1 staple is sufficient. Thanks. That way we can get going again. So the question says, Chris is putting balloons into groups for a party. If there are 30 balloons in all, how many groups of 7 balloons can she make? How many balloons are left over? Complete the blanks to solve the problem. So our problem is 30 balloons divided by 7. So let's see how this one might be different. So on your whiteboard, I want you to draw this. Malachias, only what I'm putting on here, not other pictures. 30 divided by 7. So 7 is on the outside of the bar. That's the divisor. And the dividend is 30. That's how many things we're dividing. Now, on the last couple of examples, when we were dividing 7, we would divide 7 into 3. 7 doesn't fit into 3, right? 7 doesn't fit into 3. So now we're going to use both of the numbers, right, Anthony? We're going to use both of those numbers. So since 7 doesn't fit into 3, there's a couple of things that you can do. One of those, now it depends on kind of what you've already learned in other years. So the way that, what you really should be doing is you really should put a 0 up here, right here, because that means that 7 couldn't fit into 3, and all we're doing is we're holding a place. We're not done with the problem yet. That's our very first thing. Because 7 can't fit into 3, we need to hold the place. If we don't do that, then our answer is going to scoot over into the wrong place. When we're dividing 7 into 3, we're putting 7 into 3 tens. When we put 7 into 3 tens, we're saying it doesn't fit, so we're going to put 7 into 30. Okay? And then our answer has to go right here. The other thing that you may have learned to do before was maybe you put an X right here. Some teachers use an X to show that you're marking the place. Either way, technically, would be an okay thing to do. I don't want to confuse you, so if you've already done X's right there, then put an X. If you've already done zeros there, then put a 0. If you've not done anything, then just put a 0. Because we like to kind of keep numbers up there rather than letters. So 30 divided by 7 would be 7 on the outside, 30 here. 7 does not go into 3, so I'm going to put a 0. Now that 7 goes into 30, how many times does 7 fit into 30? 4 times. So here's where my dividing comes in. 7 goes into 30 4 times. That's step number 1 is divide. Step number 2 is multiply. 4 times 7 is 28. Now we subtract. And we get 2. I had to borrow there because 0 minus 8 doesn't work. So I borrowed from the 3 and made it a 2 and then made the 0 a 10. It's also just, if you really think about it, between 30 and 28, there's only 2 numbers, 28, 29, 30, right? 2 numbers. So now the dividend would be 30 if we were filling in over here. The divisor is 7. The quotient is the answer, and that would be 4. And the remainder then is 2. So if they have 30 balloons and they want to put 7 in each bouquet, like balloon bouquets or little balloon groups, she could make 4 groups of 7, and then she'd have 2 left over. Now, let me show you why it's important. The answer would be 4, remainder 2. Let me show you why it's important to put that placeholder there. Really, okay, so it's really because if we don't put the placeholder there, later on when we get to big numbers, because we're going to multiply really big or divide really big numbers eventually, and if you don't put the placeholder there, it's hard to make sure you got everything done in the problem. So because you have 2 digits here in your dividend, you really should have 2 digits as a quotient. So when we get 5 or 6 digit dividends, girls at the table, pay attention or you have to move. When we get to a number that has 6 or 7 digits in the dividend, then we want to make sure that we have all of those numbers up there in our quotient. Okay? So by me saying 7 doesn't fit into 30 or doesn't fit into 3, if I didn't do anything and if I didn't put a 0 there, and then instead I just went, okay, 7 fits into 30 4 times. 4 times 7 is 28, and then I get 2. I can still get full remainder 2, but look at this little place right here that I've created. See this spot right here? Everybody see that spot that's right above the 0? Then it's like you're missing something. So what I'm always going to tell you is the number of digits that you have in your dividend, you should have that same number of digits above in the quotient. Because when we get to using bigger numbers or when we get to using decimals, it's important. You don't need to put 0, 4 as your answer. You just need to put 4 because you're just using it as a placeholder. And sometimes we get, sometimes we work with where we might have a 0 up in part of our answer and then we have other numbers after it when we're dividing. So it's just really a good habit to get into right now is to put that placeholder there at the beginning. Just because for future lessons it would be helpful. Okay, I want you to do this one by yourself on your whiteboard. It says there are 33 students who are interested in playing on a soccer team. Each team must have 8 or 9 students. Is there a way to divide the students to make 4 teams? This is the extend problem, so that means it's kind of hard. So listen really carefully while I read it again. There are 33 students who are interested in playing on a soccer team. Each team can have either 8 or 9 people on a team. Is there a way to divide the students to make 4 teams? If so, describe how. So think about it for a second. If you've got 33 people, could you get 8 or 9 students on a team? So let's think of first, just to help you out a little bit, what number would be the dividend? What would be the number that would go underneath the bar? Nolan, what do you think?
It'd be 33.
Because that's the number of students you're dividing. Now, what would be the divisor, the number that would go outside the bar? Hold on. Let's answer this one first. Is there a way to divide the students to make 4 teams? 4 would be my divisor on the outside. So is there a way where you could get 8 or 9 people on a team? If so, describe how. So take a moment, think about it, write your answer on your whiteboard. Let's first solve the problem. Can 4 fit into 3? No. So I have to put a 0 up here. Anytime the answer is no, I have to put a 0 up there. And then I'm going to divide with my other number as well. So do you see how I'm putting the lines underneath? It's not a bad idea for you to put the lines underneath if you're being if you feel confused about this, because the line helps you know which numbers you've used so far. So now again, when we get bigger numbers, it will also help you to make sure you do that. So now I'm going to divide 4 into 33. How many times does 4 fit into 33? How many times, Angelina? 8 times. And now we're going to multiply. That's step number 2. 8 times 4 is 32. Then we subtract, and we get 1 as our remainder. So my answer is 8 remainder 1. But if I just put 8 remainder 1, does that answer the question? Not really, right? The question is, each team has to have 8 or 9 players. Is there a way to divide them to make 4 teams? So would there be a way? Yeah? So what do you think, Nolan? What's your answer?
There could be 3 teams of 8 and then 1 team of 9.
So if you have...
There's a remainder of 1, so you could add 1 student to
right.
another team.
So that remainder of 1,
Would have just an extra 7.
they would have 1 person extra. So if you have... Since 4 goes into 33 8 times... Because 4 goes into 33 8 times. And then 8 times 4 is 32. And that's how I got that extra 1 at the bottom. So because it fits 8 times, as Nolan said, I could make 3 teams that have 8 people. And then my 4th team is going to have this extra remainder person. So they would have 9. So yes, there is a way to make teams of 8 or 9 students. 3 teams would have 8. There's nothing to keep going on. There's no other numbers over here. Right. If we use all the numbers, there's no other numbers to do anything with. What's your answer, Aiden?
6 kids quit. And then about 9 people.
But they want to make 4 teams. Okay, so if you try to force somebody to quit, then I guess you could make all teams of 4 or teams of 8. Okay, well, that would be the not nice way to make soccer teams. Okay, look. Let's look at the math example on your math paper. Example on your math paper. Something I do need to tell you though is if you're feeling confused, just know that part of the reason why you might be feeling confused might be because you don't know your multiplication facts. Because remember, if you know your multiplication facts, then you know your division facts. So if you see a number like 8 into 33 and you're going, how did you get 4? Because 8 times 4 is 32, which is close to 33. So that's how we're figuring that stuff out. So if you don't know your multiplication facts, this is going to be really hard for you. And the only way to know them is to study them. Okay, look at the first example. Ready? Eli donates his toys to 5 different charities. He has a total of 75 toys to donate. Eli donates the same number of toys to each charity. How many toys does each charity receive? So, meaning he doesn't want to have one charity get a whole bunch and another one get more than that one. So, every charity has to have the same number. So first we're going to divide the tens. So we're going to do 5 into 7 first. So how many times will 5 fit into 7? Once. 1 times 5 is 5. They've already done that for you. Then we subtract. That's step number 3. And they've already done that for you, and you get a 2. Now we bring down the 5. So now it's 5 into 25, which fits equally 5 times. 5 times 5 is 25, and then you get 0 down there as your remainder. Right, 15 remainder 0. So that means each charity would receive 15 toys. So up here, we would do 75 divided by 5.
Because the 5 on the top, 75, the 5 you got from 5 times 25, those 5 divided by 25 equals 5, and then 15.
It's 25.
25. So divided by 5.
Look at this, it's 25.
It's 25, not 5. See?
Because can everybody over here be quiet so that when he's trying to hear, he can hear? Yeah, this is how. Because right here I did 7 minus 5 and I got this 2. Then I pulled down that 5 and now I have not just 5, I have 25 because of that 2 when I subtracted. So that's what he was trying to tell you. We divided 5 into 25 and that's how we got 5. 5 goes into 25 5 times. 5, 10, 15, 20, 25. That's 5. Then that's why we put a 25 down here, because it went in exactly the right amount of times, and then we subtracted and got 0. Okay? So, again, like I showed you earlier, what we did yesterday goes with this. It's not separate and it's not a different kind of problem. It's all division. So 75 divided by 5 is 15. So each charity receives 15 toys, and you can see the picture there of what the model would look like. Example number 2. Caleb is putting his baseball cards in an album. He has 57 cards, and he can put 4 on each page. How many pages will Caleb have, and will there be any cards left over? So our division problem, they've written it here for you, is 57, which is the total number of cards, divided by 4, because he can put 4 on a page. Because the question was, how many pages will he fill up? So 4 goes into 5. That's our first step. 1 time, so I put the 1 above that. Then I multiply 1 times 4, and I get 4. Step number 3 is to subtract, and I get 1. Bring down the 7.
The answer is 14.
And now 4 goes into 17 4 times. Multiply 4 times 4 and I get 16. See how your basic facts, if you don't know them, it's going to be really hard. Because you're trying to get as close to 17 as you can without going over. So now I subtract and I get 1. So that means there will be 14 full pages of cards, and you're going to have 1 card left over. My remainder is 1. So you've got 14 full pages of cards with 4 cards on each page, and then you've got 1 left over as a remainder.
I'm very confused. How are we getting all these how are we getting these numbers if they're not saying that you're able to use them? I'm confused on how getting all
They-
the numbers.
Because they come from the word, this time they came from the word problem. For the rest of the assignment, most of it, they just give you the numbers. Look at guided practice. I want you to take a moment to try to solve the guided practice questions, and then I'm going to write them in up here on the board, on the screen, and I want you to see if you got them right. Okay? So we're going to do it a little bit differently. Normally I let you just share with a partner, but today I want to make sure that you are not just sharing with your partner, but you also can see it from the screen. So I'm going to go ahead and solve them, but I'm not going to tell you what I'm doing. Just when you're finished, I want you to check the screen. Sometimes when you have to write in and fill in on the boxes, it makes it even harder than if they just let you solve it. Yeah. Sometimes the boxes are confusing. So if you wanted to, if the boxes kind of are annoying to you, you can always just write the problem next to the boxes and just do it yourself. You're gonna get the same answer, hopefully.